All right, this is Mr. Wire. Going to go over this review with you real quick. Figure 1 and Figure 2 are similar. Which side corresponds to EH? Here's EH. It's kind of the longer side of this figure. I believe it's the longest one. So if we look on this up here, we can kind of see relatively like this is flipped over from where this is, and it's a little bit bigger. But that corresponding side to EH should be what's probably the longest one, which is going to be this right here. Now, since I'm going from this E on the extreme up to this H for this flat one, it's probably going to be U up to W for this. So UW is going to be the side that matches up. Segment below is dilated by a scale factor. When you dilate by a scale factor, you multiply. So my scale factor is 4, so 23, and I'm multiplying by 4. 4 times 3 is 12. 8 plus 1 is 9. This should be 92 units long. This one, however, you have to be careful. EF is dilated by a scale factor. It's multiplied by 2/3 to make E prime F prime. Then it tells me E prime F prime is 2. So whatever I had, I multiplied by 2/3, and I ended up with 2. I multiply by 3 to get rid of my fraction here. So I get x times 2 is equal to 2 times 3, which is 6. I divide by 2, and I get x is equal to 3. So the original EF was 3. On my next one here, I'm doing some dilating again. But when you dilate a figure, you're going to make the sides longer, or you're going to make the sides shorter. And adjusting the length of those sides is not going to change my angle. So this one stays 145. This one tells me they're similar, so I had some kind of dilation, some kind of scale factor that moves between them. So I set this up with what matches up. BC is up here at the top. It's not what's up at the top. BC is the second and third letters, so I'm looking at EF. That's this right here. So 19 matches up to 59 in the same way that 26 on my smaller triangle should compare to X. I cross multiply. I don't want to do this one on my own. This is 59 times 26 is equal to 19 times X. I divide by 19. I divide by 19. So I'm going to take on my calculator 59 times 26 and then divide that by 19. I come up with 80.73. Says round to the nearest tenth. So that's going to be X is 80.7. Determine if these triangles are or are not similar. This would normally be a little bit more labor intensive, but as it happens, I have two sides that are the same between both of these. So it's 19 as compared to 95, 19 as compared to 95, and then 25 as compared to 126. So I just have to see if all these are equal. If all these are equal, it's going to be proportional. It's going to be similar. So I check these two. I already know they're the same. So I'm just going to type that in once, 19 divided by 95, and I get 0.2. So I'm going to check this. If it's going to be 0.2, it's going to be awesome. So I go 25 divided by 126, and it comes up 0.198. Not exactly 0.2, so this is not similar. Okay. Next question is also checking for similarity, but this time we're looking for angle side angle. We got a 75-degree angle in both of them, so that's going to work. So is 18 over 90, the smaller sides, going to be the same as 19 over 95? I already did 19 over 95, but let's check it again. That's 0.2. So 18 over 90 is also going to be 0.2. These are equal. So this is yes. I have my side angle side similarity. Okay. I have the angles that are congruent. I have the sides that are in proportion. Sorry. On this one down here, similar kind of thing. But this one I have a 38-degree angle, a 38-degree angle. I have an 88-degree angle, an 88-degree angle. If two of the angles are the same, mathematically, all three of them are going to be the same because all the angles of a triangle add up to 180. So this gives me my angle similarity. This is yes, they are similar. Okay. Down here, we have this parallel line. It makes similar triangles. So I'm going to do a proportion again, but this time I just get to go straight across. 22.2 over 17.8. 17.8 over x. Again, I cross multiply. So I'm just going to do this real fast. 17.8 times 17.8. And then I'm going to divide by 22.2. 17.8 times 17.8 divided by 22.2. There we go. Get it all put together. And I get 14.27. My answer to the nearest tenth, so 14.3. The last couple questions on here. What are the coordinates of the point of the directed line segment? Look, this one is we take the x1 and we add to that the ratio number 1 over the ratio number 1 plus ratio number 2 when multiplied by x2 minus x1. So we're just going to plug these numbers in. My x1 is -8. I'm going to add to that. Ratio is 2 plus 2 plus 1, so 2/3 of -8 minus -8. -8 minus -8 is 0. 2/3 of 0 is 0, so this is -8 for the first one, which makes sense. 2/3 of the way from the number 2 itself isn't going to change, but that's your formula. For the other one, it's the same, but it's the y's. So I've got y1, which is 10, plus 2/3 of, it's going to be what, -5 minus 10. So that's -15. 2/3 of that would be -10. And -10 plus 10 is 0. So I get 0 here. This formula is what's important. Remember to keep this with you for the test. This last one is one that we did while I was gone. So we have the short side to the long side. So that's 3 over x. And then this is the short side now, and this is the long side of this one. So that's x over 27. We cross multiply. That's x squared equals 81. What number times itself makes 81? That is 9. On this one here, same thing. Short side to long side. So x over 3 is equal to short side to long side. That's 3 over 9. So we cross multiply. We get 9x is equal to 9. So x is 1. And then on the last one, same thing. Short side to long side, 5 to 15. Short side to long side, that's 15 to x. That means when I cross multiply, I get 5x is equal to 225. I divide by 5. And that's going to be x is equal to 45. Okay? All right. Hopefully this gets you through this. Remember, you can use this review on the test, so make sure to keep track of it. And good luck on your test.